All right, so this is going to go really nicely with the notes. And if all goes well, you'll have like a mod on to do homework today. That's how much they had in the first class. So let's get going.
Thank you.
Okay, get out for your lunch. And tomorrow, just so I know, nobody's like allergic to chocolate or anything, right?
No. I'm allergic to
We're
water.
doing like a lab with M&M's. It's one of my favorite things. I did a lot of them. What? Come on, guys, I'm trying to talk about tomorrow, but nobody's letting me talk because they're all talking over me. Tomorrow, we're going to be eating M&M's, but first we're doing math with the M&M's. Okay, so everyone is good to eat M&M's, right?
Yeah.
Wonderful. All right, three one notes. Okay.
I can touch them, it's not gonna be bad.
Okay,
I just can't consume it.
okay, so I need to get you seals.
Are you lactose intolerant?
I don't know if that's gonna work as well, we'll try. Okay. All right, here we go. Exponential functions. I think you'll find this very doable and familiar. So this chapter is all about exponential functions and logarithms. Okay. So the form of an exponential function looks like this. A times b to the x. So if you plug 0 in, what's b to the 0? 1. And then 1 times a? 1a. So that's called your initial value. A is called your initial value because it's what you get when you plug in 0. So A is the initial value. And then do you remember what B is called? It's all about that. Mm-hmm. See what I did there? Bad humor. Stupid humor.
I was just curious, what is the definition of calculus?
Oh, calculus?
Calculating.
Oh, calculus.
Yeah. Is it like geometry, like
Shapes and stuff.
yeah,
numbers and
shapes and
stuff.
Oh gosh. Well, gosh, put me on the spot here.
Calculator.
Calculator.
Okay, Google. Wait, say this on Mr. O, but it happens right.
Oh, thank you. Makes me feel. You're asking us to define. I'm trying to come up with a good definition without using words you don't
trying
know.
to kill time so you don't get.
I want to know.
Whoa.
Me? Okay.
This is a Ms. Green's class, I'm not trying to waste time.
So true.
I was able to waste 2 months, but.
So here's what I'm gonna say. It's analyzing functions using derivatives, limits, integrals. Words that you still don't know. Okay? That's it for now. Good enough. Moving on. All right. So now we just need to determine if it's in the right form or not. So do you have a number as your base in number 1?
Yeah.
Is x the exponent?
Yeah.
So is this exponential?
Yeah.
Okay, so this is yes. The base is the 16. And the initial value I'm going to shorten to IB. When you plug in 0, what do you get? 1
Wait, where do you plug in 0 then?
for x.
If you plugged in 0 though, wouldn't it just be, oh wait. Wait, yeah, wouldn't it just be 0?
Anything to the 0 power is 1. By definition. What's up, Nick?
So if you plug in, what is the initial value for any of those ones? Or any of the ones in the next one?
No, because this one has an A value of 1, but they don't all have that. A could be 2 or something. All right, does number 2 fit the bill?
No.
Why not?
Doesn't have a numbered base and the thing isn't x.
Exactly. So I'm just gonna write x is the base. So that's a hard no. How about 3?
No,
Why not?
it's not there. Wait, what's the thing, what's that called? Where the 2 is the I there.
Where what?
The ID, is that where the 2 is?
No, the IV is when you plug in 0 for x, but there's not even an x, right? So it's a no. In fact, this is just a constant function, right? Y equals 225. So I'm gonna put that is a no. The 2 is a no. 4,
No.
again, x is the base. All right, this next slide is purely computational. I'm gonna line this. Go ahead and try number 1, please. What'd you get?
5.
Good. Okay, number 2.
6.
Good. What's the 1/2 power equivalent to? So 3 times 2, so 6. All right, my favorite, negative exponents. Yay. All right, that's an ugly looking side. 1 over, so this is precisely why the exponent review goes really nicely with this chapter for the warm-ups. So that flips it down, and 5 cubed is 125. All right, number 4. I like this one a lot because the mistake I see most often. What's the power on this -9 technically? 0 would make it a 1. 1. Does that move? No. A lot of times, because that's a negative, people still want to move it then, right? But you only move things with negative exponents. So that stays -9 on the top. And then on the bottom, you would have 16 to the 5/2. And then we've gone over this before. How would you rewrite the 16 in the power? Square root, multiply that times? Okay, good. So square root of 16? Or 4 to the 5th? I don't know.
1024.
Yeah, did you do that in your head? What did you do? Oh, you did? Okay. I didn't see it. So that's kind of, do any of you know your powers of 2 really well? So if you instead of think of that as 4 to the 5th, you can think of it as 2 to the 10th. And then if you know 2 to the 10th by chance. Is that flower? That's flower power.
1024?
Yeah.
Percent of Indian that
What?
Elizabeth Warren.
The percent of what?
Native American that Elizabeth Warren.
Sorry.
1 over 1024.
Oh,
What is?
interesting. Okay. Oh, I'm sorry, Bailey, yeah, flower power. Yeah. Remember, flower power, 5 is the flower, so it's the power. 2 is the root. All right, guys, too much talking. Do you want that amount of time to work?
Yeah.
Yes, me too. Okay. So, next slide. You're writing formulas for G and H. First thing I'm going to do is I'm going to highlight that row. Why would I do that? And what value in the equation does that represent? A or B?
Okay.
No, X.
Wait, how do we?
Hey.
Read.
Initial
The initial value is when
So it's X.
value.
Okay.
so for G, A is 4. Yeah. Okay, and then you just have to ask yourself, go from one number to the next. I'm going to avoid the fractions just because it's easier. How do you get from a 4 to a 12? 12 to the 36.
Multiply by 3.
So that determines our b value. Okay, so b is now 3. And we have everything we need. So g, so the format is a times b to the x. So a is 4, b is 3 to the x. Questions? Can you try to write h then the same way? Use that last column. By the way, another way to think of it, if you're having trouble getting the b value, if you just take, for like this example, if you take 12 divided by 4, that gives you 3, right? And that gives you your b value. If you take 2 divided by 8 in this problem, that gives us our b value there. So either you could think this divided by this, or what I need to multiply this by to get that, either way. So either way you did it, you should have gotten 8, 1/4 the x. Did anybody get fancy and write it a different way? There's usually 1. 0.25, yeah. You could also, if you are feeling like, you could always also do that. 8 times 4 to the negative x. Yeah, you can. I don't care. I think this helps us understand the idea that it's decay better, but we're going to get to that. All right, any questions on that? All right, so speaking of growth and decay, our e to the x function, which we're going to talk about a little bit more, right? Is that growth or decay? Growth, because it's increasing. And then decay would just reflect over the y-axis and go the other way, and it would be decreasing. So that's essentially what this whole slide is going to say here. So you have a positive a value and a positive greater than 1 b value. In general, your graph would look like that, and that's called exponential growth function. And that base is called its growth factor. All right, and then the other direction, decay would look like that in blue, so that's called exponential decay function. And the base, because it's decaying, that's called the decay factor.
Yeah.
Okay. So let's make a quick table for number 1. Okay, exponents. What's 2 to the negative second? 2 to the negative first? 2 to the 0? 2 to the first? 2 to the squared? All right, and then I'm going to remind you something we did way back technically there is a plus 0 here, correct?
God.
Do you remember what that plus 0 represents on the graph?
What's the top read?
Not the y-intercept.
I missed something.
Okay,
I'm sorry.
we can always get back to it, okay? Later. Not a y-intercept. Horizontal asymptote. Think about it. This will never go to 0, will it? Even if you did 2 to the negative 1 million. It's super small, but not quite 0, right? So this always determines your HA. So maybe just remind yourself of that. So we're going to have our HA down there at 0. And I'm just going to plot those points that we found over here. Right, it's not touching. It looks like it is. It's not. Got it?
No.
We may have to come back. All right, 1/2 to the x. See how this is smaller, right? It's between 0 and 1. So that's going to be, we know it's going to be digit. So what would happen then if we did 1/2 to the negative second? 4. It's already on the other side. And then 2, 1/2 to the 0 is 1. 1/2.
Okay.
So that's one way you can think of it. And then remember that whole, we could write this as 2 to the negative x as well. So if you think of it like that, if that's better for you, then all you're doing is reflecting this over the y-axis. Remember our translation rules? Okay, so you could just do that even. Otherwise, we can just use this table. This will also have an asymptote at 0. All right, and maybe label this exponential decay and exponential growth. Any questions? All right, so we're gonna look at these via translations. So if I want to go from F to G, how am I going to move F to get G? Yeah, is it up or left? Left, because that plus 4 is inside. If the plus 4 was down at the bottom, right, that moves the HA, which moves it up and down. Okay. So this moves G, sorry, this moves this left 4. So what we're going to do is we're just going to make a quick little table. And you know what, I'm just gonna do -1, 0, and 1 on this one. Make it a little more fun. So 3 to the negative first is 1/3. 3 to the 0 is 1, and 3 to the first is 3. And because there's
Why is there a 4 written there with a nondescript arrow pointing nowhere?
this means left 4. To go from F to G, you would move F left 4.
Oh,
We're going to do that in a second. So what we're going to do, guys, is we're going to graph F first, and then we're just going to move it to get G. Okay? Okay, and then just take those 3 points and just literally move them left 4. So 1, 2, 3, 4, put a point. Point. So in red is our G. He asked if you can make F dotted, because you're technically only graphing G, yeah. Okay, so what's nice is we have the same parent function down here, right? So can you tell me in order how we would need to translate that to get G? What happens first? This would happen, that's actually second.
Under the Y.
Yes. So think about order of operations, right? Exponents first. So the negative x would happen first. Then multiplication. Okay. I think I lost my number. Okay. All right, and then the plus 4, right? So then up 4.
Wait, what happened?
Yes. So I'm actually going to graph that first. So Abby noted that, yes, this would be the HA. So first time today we've had it somewhere other than 0. So I'm going to go ahead, I'm going to put my y-axis down at the bottom. I'm going to do my plus 4. Okay, our blue function from above, see that? That's the one I'm going to move around. Okay? So let's start with, now you may not want to do this because I have an undo button. So there's my first point on F, right? So I need to reflect it. I need to stretch it by 2. So I'm currently at 3. Where am I going to end up? At 6. There's my stretching by 2. And then up 4. So where's my final resting place? And 10. Negative 110. There's the sequence of events. So reflected, doubled it, up 4. Now take this point, 0, 1. Is that gonna move if I reflect it? No. Double it, I'm now at 2. And then up 4, I land here. Started here, that was this point here.
Yes.
Reflecting it doesn't make it move.
No.
It's at 1, I'm gonna double it, I'm now at 2.
Mm-hmm.
And then up 4 puts me up there at 6.
Okay, that's what I thought. And the other point is just kind of there.
Well, that was the previous step.
Okay.
Here, we'll do the next one. Watch as I do it, alright?
I will.
Great. 1 second.
Whoever invented the smart board must be terrible at his job.
Alright. Alright. We started here. Okay, watch. Reflecting goes here, right? Yes?
Yes, I'm watching.
I'm at 1/3. What happens if I double 1/3? 2/3. So sorry, it's not gonna be kind of on top of itself. And then I need to go up 4, right? 1, 2, 3, 4. Yes? Paul?
Mm-hmm. Yeah, I'm with you.
Okay, that's it. We're done.
Did you start with 1/3?
No.
What you did? Did you start with
Yeah, that's what I started with. That was my.
Okay.
That became this point. The 0, 1 became that, and then make.
Are we allowed to do that with the table instead of manipulating the graph?
In fact, the last one we're gonna do today, I'm gonna show you with the table instead of manipulation. All right. Anything else? Okay, the next one, I don't need you to get your calculator out yet, just watch. I'm not gonna go too in depth. All right, so you guys are familiar with the number E, right? A little bit. 2.718. Okay. Now it's kind of like pi, right? Pi doesn't just come out of the blue, does it? What is pi? Like number,
Circumference divided by diameter.
right? So back in the day, right, they were like, hey, every time I take a circle circumference and I divide by its diameter, I'm getting the same number, right? So, of course, they used other numbers to approximate it, but kind of the same with E. They looked at this limit. Now, I'm not going to go too much in depth because I'll go over it a little more next week. But if you look at 1 plus 1 over x to the x, okay, and you make x go to infinity, so like 1, 10, 100, etc. And I actually have them in here from earlier. Once you get to 1,000,000, look at that, 2.71828. It's tapering off, and it's becoming eerily close to actual E value. And I don't know if I say the word PERT, if that means anything to you from Algebra 2. You remember P, E to the R?
Yes.
We're going to go over that next week. But this is kind of the driving factor of PERT. So anyway, we're not going to take time to fill in that table. But basically, just write an arrow and say this is approaching 2.718, which is E. Okay? So as x gets bigger, this value is going towards E. Okay? And really why I mention it is because we have an exponential function, e to the x, it's our yellow one up there, right? is one of our small basic functions. So actually, we're gonna go through this quickly here. We did this at the very beginning of the year. So what's the point that all the exponentials go through? Assuming they're not shifted up or down at all. 0, 0,
Yes.
0, not 0, 0, 0, 1. And then I'm gonna be sketchy about this. What if I plugged in 1? What is that approximately? 2.718, right? E to the first. So 1 is about 2.7. All right. So there's our E. I just plotted 2 points. All right, so since we've done this before, tell me anything about the function. We don't have to go in order. Give me something. One of those items. It's bounded below. Good. Good. Right. The main real.
There.
Peyton.
The range is like negative and, no. 0 to negative, no, 0 to infinity.
Good. Yep. What else?
There's no vertical asymptote.
No vertical asymptote. In fact,
Worse than yesterday.
exponentials won't have any ever. Josh?
I know, but.
X-axis symmetry. Are you sure?
Yeah, no, we watched, sorry, my bad.
I'll
Yeah,
tell
it
mom
does.
this afternoon.
No, it doesn't. No, you're not. So can I fold it over here? Is there even a graph here? No, so it can't have x-axis. A mirror image of y-axis like would have to been something like that, right? That doesn't work. Want to change your answer?
So I guess that's y-axis symmetry? I don't know.
So if I fold the graph, Josh, if I fold the graph, it's gonna do that.
Right,
There's no graph there.
right.
Graphs that have y-axis symmetry look like that.
I'm thinking of reflections, I'm sorry.
Okay, so what do you want to say for that?
There's no symmetry.
Okay. Something else, Nick?
It's increasing the longer the game.
Good. Abby, something else? So,
Oh, okay, never mind.
remember how we read graphs, left to right?
I know.
Something else?
Continues on the domain.
Yep, continuous on all reals. Something else?
There's no extrema.
No extrema. All right, we did great. And now we just need to do end behavior. Now, this is getting much better progress. Beginning of the year, right, this was really hard. Okay, but you guys are getting better at it. So, just to refresh you, this means as I move left,
Negative infinity.
so if that were true, it would have to do that.
Oh, 0.
There you go. And then as I move right, where is it going? There we go. Yeah, you did have to do some of that. All right, so that's our old one. We know it. You did well. You know, progress you made at the beginning of the year. All right, we're just gonna do one more, and this one we get. All right, last one. Okay, so I don't know what's happening, but
That was the bell. Oh, man, it's been crazy.
where's the HA? I just kind of want to show you something before, and show you how you can answer a lot of these actually before you graph it if you wanted. What does this negative do?
Flip it over the X.
So instead of doing this, it's going to do that. So that gives you a lot of information now, right? So you have HA is y equals 2.
Okay.
Yeah, now it's bounded above. Good.
It's 2.
Throw them out there. Just tell me. I heard no extrema. What else?
Its domain is all real.
That is always true. Yep.
No symmetry.
No symmetry.
Its range is 2 to negative infinity, right?
Oh, you're so close. You just got to go in the other order.
No, negative infinity to 2.
There you go.
I can only be smart all day. Can't have one right
It's a classic
answer.
mistake. People just like to go top to bottom, go bottom top, small mistake. Decreasing all the time. No BA. Oh, let's just keep going. Okay. You can do all of them without like a pretty graph, right? So if I go to the left, where am I headed?
0.
So as I move left, it's tapering off to 2. And as we go right, got it, nailed it.
Twice a day.
Oh, sorry, that's
No, I borrowed that smart from the last test. So that thing I got 0. It's like a circle.
All right, when you go to actually graph it, utilize the space on your graph by putting your y-axis higher, or sorry, your x-axis higher. Do that. And I like to use a table. Unless I've graphed 2 to the x already, I'd rather just use the table. I know we did it earlier, but just to give you another option, you can put it in here. So was that -1 plus 2? Okay. So there's the graph, and then you can grab a couple of points from your table. Again, I'm just going to be simple and use those. -1, 1.75. And then 1.5, and then 1. Down the road, you'll have a calculator and a no calculator part on the upcoming test for this, but that's a little ways. Thank you. You'll know what to study. We did it. Yo, hold on. You can probably finish your homework.
Oh, dang it.
The answer key is up here on the board, and it's on my website. All good? All right. Be productive, please.
I'll be very productive.
If you need to go back and all this. Vertical pizza. Go to the top of the word. Well, no copy and paste. Yeah. That's what I know.
I feel like I want to come back from that.
Yeah. I mean, not really. Yeah. You go back to exponential growth to the next.
I haven't said you are bound.
Right, go. Thank you. It's the right-hand bottom side.
Some people hate it.
Yeah.
We only did discuss.
I'm gonna do it. You're looking for
Yeah, good at it.
Since you're laying down, you have all that done.
Yeah, I have those on.
Right next to that K here, and exponential growth here. So now you're not gonna use this time to get caught up on anything?
You know what, I'll use it for my homework.
That sounds probably like a pretty good idea. That's why she's giving you this time.